Today I'm going to look at some unknown circuits in these little custom enclosures. I recently had the opportunity to adopt some electronics that I have no idea the history or purpose on, but of course I'll take a look at it and see if there's anything salvageable or directly usable. And from what I can tell so far, just starting with these two, these look like basically the same sort of thing. On one side, it looks like, I assume, an audio out. One looks like a 1/4 inch jack, while the other's in an 1/8 inch, maybe. Then on the main unit, one of them has a volume control, and it's a potentiometer with a switch. The other one has a switch for on-off, and I assume a volume control. And it looks like they both have an Electret microphone on them, and there's nothing else, no power source. So I figure it's meant to have a battery inside. And it has Velcro on the bottom. So I don't believe this would be for maybe a vocal microphone purpose, but maybe acoustic musical instruments. If you Velcro this somewhere nearby, maybe you can pick up audio and plug it into something. But I don't know. I don't know what it was used for. So I want to take those apart. And this one, it's a guitar effect pedal. It's an old script logo, MXR, and under the word buffer, Phase 90. I wish this was the real thing, but it looks kind of customized. There should be a on-off switch here and maybe a speed potentiometer, but we just have what looks like something else going on. Also, the bottom, it's red. It doesn't match, so I don't know really what's going on. It only has one screw. There's an audio input and output jack for a guitar. The reason I know about this, I have the more modern MXR Phase 90 EVH version, and it has this button called script, so it puts it into script mode or block logo mode, which was a different era. So I want to rip this apart as well, but it does say buffer instead of Phase 90 now. So we'll get to that, see what's going on. But let's start with these Electret looking microphone box things. I'm just going to open both of them first. All right. Oh, it's got a battery in it. It probably is thousands of years old. It doesn't appear to have leaked and corroded. All right, we got 32.9, 33 millivolts left on this battery. And inside, whoever made this went to the trouble of putting this little partition here for the battery. So we have the 9-volt source, Electret microphone, potentiometer, output jack, and the only other thing I can see in there is an electrolytic orange capacitor. And I'll take this apart to see what else is going on. Battery minus terminal goes to one side of this pot and also to ground on the output jack. And it looks like part of the electric goes to ground. The other part goes to the capacitor, 10 micro 40 volts. And the wiper black wire goes to the signal out of the jack. What's in this other one? This box seems older. It's also got this interesting kind of dark bluish green tint to it. At least that's how it looks to me. It could be just a weird discolored black. This one also has a battery and less room to maneuver. This battery also looks relatively clean. Oh, this is 7.3 volts. And it's off screen. This is weird. I don't know, maybe this thing has been used more recently? And I don't see anything special, any active circuitry in here. We have the same thing, a power switch, power source. I see an electrolytic down here and our resistor here. Output jack, microphone up here. So yeah, it's not a fancy preamp or anything. It's just a powered Electret microphone meant for something. And most likely music pickup related as opposed to standard hobby project. So I wonder if these are in working condition. Trying to trace through this Electret microphone circuit. This is what it looks like we have with our 3-terminal Electret mic. It's going to 9-volt supply and ground with a switch on the plus 9 volts. Then the audio output goes through the 10 micro series DC block capacitor, and the output just goes through this level pot, which takes the signal in, and then the wiper can move between full signal or all the way down to just ground, attenuating the signal as we go toward ground. So that's how we get our volume out. So if I hook up a battery to this and an audio cable to this orange amplifier, turn it on, and the volume's on max here. Now I'll turn on this microphone and, ooh, nasty feedback. Oh yeah. Otherwise, it's working. Now if I talk into it, I don't know that we can distinguish me talking directly and me coming out of this small amp. Is this distinguishable? Well, if I make some stupid noises, yep, it's distinguishable, so it works. I don't know how well it works for whatever purpose it was originally put together, but there it is. No sense in hooking this one up. It's essentially the same circuit, or at least the same concept. But there we have it. And now this one, I'll have to take this one screw out. And it's not coming apart. Hope they didn't glue it. Oh, this corner. Well, that's definitely a custom circuit, but this doesn't look like it's MXR branded, so I don't recognize this. It says FRAP, Flat Response Audio Pickup, a division of, it's hard to read, Strobotronics, San Francisco. Looks like we have a corroded battery. Radio Shack. I remember the free battery cards for these red ones. Okay, so this battery's dead. I'm not going to measure this. The battery holder is falling apart. Oh, the terminal came right off on the battery. All right, well, this is the input side of the original product, and it looks like it says guitar and amp, so that will be output and input. I can't read upside down and out of focus. So we have an LF351 op-amp circuit, and it looks like a couple of capacitors, some powerful resistors. I don't know, is that at least 1 watt, maybe even 2 or 3 watts? I will assume 0.047 is a couple of capacitors and a variable resistor. What does that say? I think it says volume. Oh, there's more on the other side. Another capacitor, another resistor. Did somebody draw a ground right there, or is that a happy little tree? Don't know. Well, hey, it's a Radio Shack circuit board. Now, being an op-amp circuit in an audio application, and the word buffer on here, I will assume this is just an op-amp buffer circuit, as opposed to an op-amp with distortion or overdrive capabilities. So I'll be curious to power that up and just check it on the oscilloscope with a signal generator in and the scope out. But the reason to have a buffer in a guitar signal chain, one reason would be if you have long guitar cables. Cables, of course, have capacitance, and so it kind of acts like a low-pass filter, and you'll lose some clarity, some high-end frequencies if the longer your cable is. So if you take a nice ideal op-amp buffer type circuit with a high impedance input and a low impedance output, you can drive those loads better and preserve your signal integrity. And likewise, even certain pedals going between one pedal to the next, or a guitar to a pedal to an amplifier input, a lot of pedals will have buffer circuits built in, but some don't, and so then you can get weird interactions from one output to the next input and so on. So again, you might have one stage of a circuit loading down another stage of a circuit, killing the quality of your expected guitar tone. So the buffer helps you isolate everything and not have all these different components interacting with each other and preserve your signal. So it looks like somebody was converting this old Phase 90 into this, which I wish this was a Phase 90, but let's see if it works as it's supposed to as a buffer. To test the buffer circuit, I'm using a signal generator for a sine wave, and that goes to a mess of cables hanging in the air, which go to the input of the buffer circuit and the oscilloscope. I put a new 9-volt battery clip on there because the other one was disintegrating and the wires fell off of it anyway. And to the best of my ability, I tried to trace out this circuit. I couldn't see what was written on all these capacitors and I didn't want to touch it. It's probably going to fall apart. But there's what I came up with. The signal comes in here and it will see a 330K pull-down resistor, and that sets the input impedance to the circuit. We have a series DC block capacitor, and we come to a non-inverting amplifier with a 351 op-amp. We're running on a 9-volt battery, so the input is biased up halfway between 9 volts and ground, and that bias supply is filtered with a capacitor. So now our audio signal has the DC component removed if there was one coming in, but we add our own 4.5 volt DC bias here. Now the audio can swing positive and negative equally, and the gain of this circuit is set here with a 560K fixed feedback resistor and the little volume potentiometer. That's another 500K pot, just configured as a variable resistor across the 560K. So by changing that pot, we can change the gain. And the gain is also frequency dependent because we have a 2K resistor and a capacitor to ground of some value. Then on the output, again, we have a DC block capacitor to remove the DC offset. And we have several hundred ohms of series resistance here, which generally helps an op-amp drive capacitive loads, such as a music instrument cable. So let's connect up the battery and look at the scope. This may be a bit jumpy sometimes because of poor wiring, for one thing. The yellow channel 1 is the sine wave input from the signal generator, and the blue channel 2 is the output of this buffer. Right now I have 1 kilohertz at 100 millivolts peak to peak coming in. I've adjusted this volume pot all the way to one side. So with 100 millivolts peak to peak in, we have 65 to 75 millivolts peak to peak out, so it's a little less than unity gain. Now I'll just try adjusting it, and it's jumpy, so I got it almost at unity. So it's possible to set this pretty much as a unity gain buffer. What you get in is what you get out, and you just get better cable driving capabilities. And if I adjust the gain, let me change the scale on channel 2. I'm starting to see some clipping here on the bottom at least, and I'm almost around 1.6 volts peak to peak out for the 100 millivolts in. I'll back it off a bit. Well, first, go into all of this. Now maybe it's going to be a good distortion effect instead of a clean buffer. Maybe around here, 900 millivolts out or so. Maybe it still looks clean. So now I'm going to put the signal generator in sweep mode, and it's going from practically nothing in frequency all the way up toward 20 kilohertz. And what I'd be looking for, I've always got around 100 millivolts peak to peak in. I just want to make sure I don't roll off my signal amplitude, at least not very much, up to about 5 or 6 kilohertz at least. So let's say it's 1 to 1.1 volts peak to peak. 5 kilohertz, still there. 10 kilohertz, still there. 15 kilohertz, still there. We're above guitar frequencies now, so it looks like this is an okay little amplifier or buffer. Well, there you go. Some old electronics, all custom made. Seems to work fine after however long it's been, but this pedal originally being from the early 70s, and this looking like it's one of the original issue, this stuff is 30 to 40 years old most likely. Always fun to look at old technology and see if you can maybe find a use for it. I might try to build myself an actual clone Phase 90 circuit for this. I don't know if I need a buffer. Project for another day. Thanks for watching.